All right, this is your Stat Sensei, and we're going to look at a one proportion hypothesis test. This was an AP question, and it was year 1998. It was question number 5. So a large university provides housing for 10% of its graduate students to live on campus. The university's housing office thinks that the percentage of graduate students looking for housing may be more than 10%. So basically, our status quo is that it's 10%. So this is kind of our claim. The housing office decides to survey a random sample, that's important, of graduate students, and 62 of the 481 say that they are looking for housing on campus. So this right here would be my sample size. This would be the number of successes. So this would be my X. Say that they're looking for housing. On the basis of the survey, would you recommend the housing office consider increasing the amount of housing on campus available to graduate students? Give appropriate evidence to support your recommendation. So we'll do part A first. So it says, part A, our claim was the 10% we're looking, but we're concerned that it's greater than 10%. So our null P equals 10%, our alternative P is greater than 10%. Let P equal the true population proportion of graduate students looking for on-campus housing. Must always define a parameter. The order you do these two is up to you. Conditions, random sample, and it was a random sample of 481 students. All right, or a random sample was given, I should say, and is less than 10%. So we have 481 divided by 0.1. Reasonable to assume that there are at least 4,810 graduate students, probably a large school. So in this case, NP 62 said that they wanted on-campus housing. That's greater than 10. And it's not the 10%, it's NP. Remember, NP and NQ must be greater than or equal to 10. Well, that's greater than or 10. And then in this case, we had 419. You're going to go, gosh, Mr. Spencer, where did that 419 come from? Well, we had 481 minus the 62. That's 419, said that they didn't want it. That's greater than 10. Because both of these two together make up my normality. Because both are greater than 10, the sample is large enough. And remember, these two together make Goldilocks, all right? Not too big, but big enough, all right? So in this case, we had 62 out of 481 wanting graduate housing. That was our sample. So our P hat equals 0.1289. I'm writing my formula down, and it's P hat minus P over PQ divided by N. Remember, if you use the Q, you'll always have to tell them, hey, Q is 1 minus P, or you can just write 1 minus P. So we have 0.1289 minus 10%, and then 10%, 90%, and 462. Please remember, hypothesis test, these have to match. That's different than a confidence interval. Okay, so here we go. Stat, test. One proportion z-test. Our claim is 0.10. The number of people said, the number of grad students who wanted it were 62 out of 481 surveyed. And we were concerned about it being greater than, the actual being greater than. And sure enough, we get a z at 2.11 and a p-value of 0.0173. That p-value is less than our alpha of 0.05. We reject the null. So our p-value is 0.0173. We reject the null. There is sufficient evidence that alpha equal 0.05 to suggest the true population proportion of graduate students who would like on-campus housing is greater than 10%. There is something missing here. We need to put this in simplified terms. We need to answer the question. And the question is, on the basis, would you recommend the housing office consider increasing? And the answer is, based on this, based on this sample, the housing office should increase graduate housing. All right. Based on this sample, the housing office should increase graduate housing. Now, in addition to the 481 students who responded to the survey, there were 19 who did not respond. In other words, our sample wasn't really 481, it was really 481 plus 19 equals 500. So our sample size was 500. If these had responded, is it possible that your recommendation would have changed? Well, we recommended that they would increase housing. So we would want to know, gosh, what happens if they didn't? So we're going to change our sample proportion. Instead of being 62 out of 500, 62 out of 481, it's now 62 out of 500 because we changed our sample size. So this changed to this. And then we're going to rerun the test. All right. We've already done all the conditions, etc. And as it turns out, we plug in and notice this is still the same here, but the p hat is what's changed because this is now 61 over 500 or 62 over 500 as opposed to 62 over 481. So this is the only thing that's changed. All right, and we get a Z statistic of 1.789. Let's do that real quickly. Stat test, one proportion Z test. And all we're doing is changing our sample size from 481 to 500. And we get 0.0368. All right. And 0.0368 is less than 0.05. We reject a null. And to answer the question, the decision would not have changed. You got to make sure that you answer the question. Always, always, always be sure to answer the question. So we wrote the summary up here, and then based on the sample, the housing office should have increased graduate housing. Here we ran the test real quickly, and we answered the question. Make sure that you show that you reject the null. You did not have to write anything more than what we have here. All right, appreciate you watching. I hope that helps you out with sample proportions. Thanks. See you in the next one.